Courses in the cement industry. Present to you. In this session we will explain Rotary Kiln Erection.
Phillips Kiln Services, the specialty contractor for your rotary equipment projects, delivers on time, on budget, with guaranteed quality from the ground up. Successfully completed projects are a result of good teamwork. When it comes to setting bases, placing rollers and bearings, mounting riding rings, installing shell sections, mounting and aligning bowl gears, installing drivetrains, and overall alignment certification, use the Phillips Advantage. What is this advantage? As a 100% employee-owned company, we are fully self-sufficient. Phillips employs all our own project management, support staff, and field crew. All have a stake in the company. All have an interest in doing it right. We own and maintain our own tools, hardware, and equipment. Our trucks arrive fully equipped, carrying everything from small hand tools, power tools, welding machines, right up to the large towers needed to support the shell during installation. Everything that is needed for a given project. A project such as a new kiln installation may be a once-in-a-lifetime event for the owner. With Phillips, it's a routine task. Through many years of experience, along with the special equipment and techniques developed over those years, Phillips offers a unique service to the kiln owner. Choreographed is not the usual term used to describe kiln installation, but within the confines of deadlines, a shutdown, or a project completion date, effective utilization of those hours, day and night, depends on the team members executing the plays on cue with minimal instruction and doing it right the first time. That's the Phillips Advantage. Any structure is only as sound as its foundation. The first critical step is the careful positioning and setting of the base frames.
When you're setting a base frame, the primary items of concern are the design slope, elevation, and axial position of the frame. The first thing that we look at when we're setting roller base frames is the design parameters. So we'll get the prints, review the prints, define all the critical elevations and axial positions of the various base components. Then we'll go out and set the actual reference benchmarks on the kiln, both elevation, center line, and axial position, so that when we use our optical instruments, we can use those targets to check the position of the frames. Center line locations, usually within a millimeter or two, is acceptable. And the axial position is plus or minus 2 millimeters is acceptable for that. The tolerance generally accepted for kilns is plus or minus 0.02 of an inch per foot, or plus or minus 0.02%, which is roughly equivalent. Generally, we're looking to get the elevations within about 0.05 of an inch is what when we're looking across the width of the base frames, we're looking for elevations that are plus 0.05 of an inch or a little better than that possible.
Exacting work. Once shot in, tightened down, and positions verified, the grout is poured. It all starts from the grout up. Once the grout is cured, the bases are ready to accept the rollers and bearings. Now the rollers must themselves be precisely located so that the kiln will be properly supported on them. While the base frames and roller placement work continues, the various sections of kiln shell are being pre-assembled on the ground. Shipping restrictions usually mean that a kiln shell is delivered in sections. To minimize the number of joints that must be completed in the air, the sections are put together in sub-assemblies on the ground. Fit-up is accomplished using dogs to make the plates flush, push-pull bolts to control the gap in the joint, and strong backs to mechanically secure the joint for alignment measurement and welding. A successive series of run-out measurements at the joint and at the ends of the section are made to assure the pieces are set in line with each other. With their alignment set to the manufacturer's specifications, they are then welded together. To complete the joints, submerged arc welding is used to produce excellent quality joints quickly. Non-destructive testing using ultrasonic technology assures that all the welding meets the required standards.
We're going to assemble 3 pieces of shell can on the ground. We've got them set up on temporary rollers and a temporary drive system. The hardware is installed to enable you to make an adjustment if that's necessary. We put the temporary hardware, tie the cans all together, and then we'll rotate the kiln, take measurements at each weld seam and on each end of this section to determine that the shell is straight. Once that's determined, at that time, then we'll set up our sub-arc equipment, install backup strip, and weld from the outside. Get a full weld from the outside. At that time, you can go inside, remove your hardware, back gouge, back weld, and the piece will be ready to go to the air.
The sub-assembly work includes the mounting of the riding rings, which will support the kiln as it rotates. The filler bars, sometimes referred to as shell pads, bearing plates, or chairs, are carefully located and trapped onto the shell with keeper blocks. Often the filler bars will not be directly attached to the shell. Instead, they are trapped and retained by smaller blocks. Only these are welded to the shell. This is in consideration of the differential thermal expansion that will take place when the kiln goes into operation. The support rings are then slipped into place. Only after the completed shell is placed onto its support rollers on the pier tops will the tires' positions be permanently fixed. The size of these sub-assemblies is only limited by the available lifting capacity and by the obstacles that must be avoided in getting the shell sections into position on their pier tops. The area where the cranes will maneuver is graded in preparation for the lifts. The lifts must be carefully planned and meticulously executed since the cranes actually walk the shell into position. The weight of each piece and its center of gravity are taken into careful consideration. Safety is a primary responsibility for everyone on the job. Wearing appropriate clothing, hard hats, safety glasses and shoes, body harnesses, goggles, face shields, as well as marking off restricted areas are among the many standard practices followed by Phillips to assure a successful job completion. Jockeying the pieces into position takes patience and coordination. Nothing is rushed. Nothing is left to chance. Before the next shell section is lifted, the sub-assembled gear is slipped into place and roughly located. Temporary adjustment bolts are fitted, which enable the gear to be perfectly positioned when it comes time for its alignment. The next section of shell is then lifted into position. Once again, teamwork, coordination, and safety must go hand in hand. What appears to be taking place in only minutes has taken days to prepare. The joint of the 2 kiln halves is secured on the inside so the shell becomes self-supporting but leaves flexibility for adjustment. As before, when the initial sections were on the ground, this is accomplished by using the push-pull bolts for axial adjustment and dogs for the radial adjustment. Precise fit-up means attaining 3 objectives. First, the sections must form a straight tube axially. This ensures that the riding rings will run true. Secondly, radial plate alignment must be attained to prevent steps that would interfere with proper refractory installation. And thirdly, it must produce a correctly spaced joint that can be properly welded. Once the shell is so fitted, strong backs are welded into position, locking the joint for alignment verification. The most critical phase of the work now begins, the alignment of the shell. This requires that the entire kiln be turned. A set of temporary drive rollers positioned directly against the shell accomplishes this. Once again, Phillips technicians make a series of run-out readings directly on the shell joint, at the shell ends, and any other points of interest to show how straight it is. If correction is necessary, some of the strong backs will be cut free to permit adjusting the shell joint so that it does not crank. This process may be repeated once or twice until it turns as a true cylinder. With the kiln owner, the kiln manufacturer's representative, and Phillips site manager satisfied that the shell is properly fitted and aligned to specified tolerances, welding begins in earnest. Welding is planned in sequences that preserve alignment. Rapid and heavy deposit of weld metal can distort the axial linearity of the shell. These forces must be balanced by depositing weld in alternating locations 180 degrees apart. The submerged arc welding process is used to complete the exterior portion of the seams. This necessitates turning the shell at the precise speed to match the speed of welding. The welding continues day and night. Once the outside of the joint is complete, the activity shifts to the inside. First, all of the fit-up hardware is removed. Then the initial root pass that was laid in from the outside is removed from the inside of the shell using a carbon rod air arc, a process referred to as back gouging. This is to remove the inclusions and imperfections that it contains. Once removed, the joint is ground clean and filled. As always, the quality of this final shell joint is verified by non-destructive ultrasonic testing. The kiln tires must sit squarely on the shell so the rollers contact uniformly across their faces. In order to accomplish this axial alignment of the tires, the two-dial indicator method is employed. This allows adjusting the tires to run true to the axis of rotation of the shell, uninfluenced by the axial drift of the shell. Once the tires have been correctly set within the prescribed tolerances, the permanent retaining blocks can be welded in place and the temporary adjustment hardware is removed. The gear also has precise alignment requirements. The axial alignment of the gear is more critical than tire alignment since it will be rigidly fixed to the shell. Again, a double dial indicator method is used. The two dial indicators are placed on the same face of the gear, but 180 degrees from each other. Since the kiln shell can never be completely restrained from moving axially during its rotation, the use of two indicators makes it possible to mathematically eliminate this effect from the readings. Radial runout measurement, on the other hand, is accomplished more simply with only one indicator. Repositioning the gear radially continues as long as the plotted readings exhibit a sinusoidal pattern. The manufacturer's tolerances must be achieved. With the gear now properly located and aligned both axially and radially, welding of the gear supports to the shell can be completed. The remaining drive components, pinion, gear reducer, and motors are now also assembled onto the drive base. Alignment of these high-speed components requires even more precise methods. The use of prism reflected and triangulated laser light makes easy work of determining the shim requirements and the necessary adjustments for proper alignment of all the drivetrain components. First, the pinion is aligned to the gear. Then the remaining components follow sequentially. It takes many months to construct a cement plant. A variety of contractors bring their skills and know-how to complete such a project. Phillips Kiln Services has completed its portion with the installation of the heart of the cement plant, the rotary kiln.